Good morning. How's everyone doing today? Oh man, oh man. I'm trying to pull up a separate stream monitor over here because we got to monitor that. Been having some technical difficulties with the quality of the stream lately. So, there's that. Good morning, everyone. I hope you guys are doing okay. I hope that the homework is going well and that you guys are understanding the concepts that we've been learning. I also hope that you take a moment and you kind of take an inventory and you see very quickly how much you've learned in 4 weeks. Do you realize it's only been 4 weeks? That if we don't include week 0, which was just orientation and trying to learn about problem solving and trying to make new friends and things like that, if you don't include that, it's been 4 weeks of actual code learning. And I want you to kind of take a moment, for those of you who are new to coding, I want you to consider how much you are capable of at this point compared to when you first showed up to school. Because I think that if you take stock in that for just a second, you'll be kind of surprised and impressed at what you've accomplished. There we go. Now I can see what's going on. Oh, I got to turn that down though. All right. So, I apologize. My voice is a little rough today. Let's see. My mods online today are going to be Quintanilla, Showerman, and Barker. Their job is to watch the general channel, or the questions channel would be even better, under the tutoring section. Watch the questions, and let's see where we get the most curiosity, the most inquiries. And then as we have someone who's ready to ask a question or a question that needs to be asked, then they will move them into the waiting to be moved voice channel, which I will see, and then I will grab you and pull you into my channel just as soon as I'm ready to take a, I don't know how else to say it, take a call. I don't know, take your question live. So I'm also watching the stream online right now. And again, God, my frame rate is garbage. What is going on? Okay, so there's a little bit of a delay, but we're still there. Okay. Boop, boop, boop. So I usually like to start I like to start this off with just, let's talk about something that's useful in the meantime while we're waiting for questions, right? So I'm gonna get rid of all that, and I had a demo for a specific student. We don't need that right now. That was actually for the last stream that we did. We've been talking a lot about, well, this last week we talked about arrays, and we talked about the beginnings of reusable code and things of that nature. You know, one of the things that we find that we have to do a ton of, just over time, right, is take in some array of something and print it to the screen, right? In fact, it's not uncommon that we want to take an array of a certain type and print it. We also want to take an array of a certain type, and then we want to populate it. These are fairly common. These are fairly common scenarios. And once we know some more advanced tools, there are ways to write that code so that it applies to every kind of array. In fact, let me think about this for a second. I think we can make that happen. I think we can make that work today. I'm trying to think, oh, that's true because of the way that generics work in Java. So I'm trying to reconcile my Java knowledge with my C# knowledge, right? So please forgive. I'll tell you what, let's keep it really super basic for right now. And then from once if I feel like it's a good idea to kind of get more advanced, we will. My concern is that in order to show you how to write these methods so that they work for every kind of array, then we have to look at something called generics. Generics gives us the ability to define methods that have to operate on a type without specifying the type first. You know, normally in our code, we would do something like, we would have something like, oh, by the way, I'm just kind of curious. Well, yeah, don't worry about it. We'll get to it. But normally in our code, we would do something like, here is public static. Oh, you know what? Hang on a second. There we go. We'll get the old demos out of the way. We'll do public static and void, and then we'll say populate array. Normally we would say something like int array, and then I'll just say R, short for array in this case, because we don't know what the context of those numbers is. And then from here, we would go inside and then we would do our process, logic for random value. I'm trying to think. Generation. There we go. Random value generation, and then we would store each value in a spot in the array. And we would do this in cases where we would use this method for things like, let's test the rest of our code given the context of what's valid. For example, if I were writing an application to do, say, grade book analysis, then I probably want to have scores between 0 and 100. Maybe if I include extra credit, it could be 0 to 110, 120, or 0 to 150 or 200, whatever the case may be. Figure out what the range is. And then we would populate the array with just random values in that range so that then we could pass it through our median finder and our, let's see, what are some other terms here? I suddenly can't remember anything today. I'm so, so we have the mean or the average. We have it's not the median though. It's the, I suddenly can't remember the term for when you have a number that occurs the most in a bag of numbers. I can't remember. Anyway, we could also do frequency analysis. We could list out how many times each score appears. We could do min max, what's the highest, what's the lowest, that sort of thing. And so what we might do is we might use this method to populate that array with random values in an acceptable range, which means we probably need to have something. We might do like a min max kind of thing, but we would write our method like this. If we wanted the ability instead to, and actually, you know what? A better example would be after we populate the array, we probably want to, freaking Eclipse, we probably want to print the array out or at least produce a string that we can print if we wish. So I'm going to make a string here and then we will say array to string, which takes in this case, we'll do an int array again. However, this method here is actually, the concept of this method applies to any array. This previous one, if we're going to generate random ints, that's not the same thing as generating a random car or generating a random movie. That's a different set. That's a different process. We probably have to write a different method for that. But if we want to stringify an array, if we want to get an array and turn it into a string version of itself so we can see every value, or maybe want to separate each value with a comma and then so much space and da-da-da-da-da. That is a concept that applies to every array. It's not just an array of ints. So how, like for example, if all we wanted to do was print the contents of the array to the console of that, or I'm sorry, not print, but to concatenate it into a string so that the string can be used elsewhere, right? Then we might do something along the lines of, let's see, I just want to make sure I didn't miss anything. Okay, we might want to do something along the lines of, let me take this moment to teach you something cool. There's an object called string builder. And we like string builder a lot because it helps us conserve on the usage of memory during the creation of strings, which is something we haven't really discussed in class yet. But we will. And essentially, whenever we concatenate strings, we end up making a bunch of little tiny strings that start filling up memory space. And then we make our superstring, and then any of the strings that are no longer needed eventually get removed. However, normally we don't care about that because we have so much memory by today's standards. But if you're in a limited environment, if you're in an embedded system, or if you have a very complex application and you need to conserve memory, then all of a sudden string concatenation doesn't make a lot of sense. It's extremely expensive, and you can do it. If you're only going to concatenate 2 or 3 or 4 strings, probably not that big a deal. Once you get beyond 3 or 4 strings, it starts to get expensive. So I like to use String Builder. I like to have a builder object, and what String Builder does is it keeps track of the chars as we pass strings in so that the strings can be very quickly removed or disposed of in memory. And then when we're ready for the whole thing, we ask String Builder to turn itself into a string, and then we get the final result. Here's how that looks, by the way. At the end of this method, we would say return SB, that's the name of my string builder, dot toString. My voice is rough today. I'm so sorry. Not getting sick, just my voice is tired from a week of lecturing, not just you, but my own children and, all that stuff. So apologies. Now, normally what we would do here is we just go into an enhanced for loop for every string S in the array. We would then say SB dot, I've got this set up as an int array, right? Sorry, it should be for every int I. And then we do in the array. Then we do SB dot append. And then we can pass it I. Now, I'm going to double check this really quick. Yeah, it's okay with that. We're passing in I. What happens is that number, that int behind the scenes, gets turned into the string representation of that int. So if I have the int 7, it's going to become the string 7, right? As you and I know, the string 7 and the number 7 are not the same thing. And so this behind the scenes is going to convert that int into a string version of itself. And then we're going to append it into the string builder. And then we will append the new line character. That way every value appears on its own line. Of course, we could also do some other things. We could put in a comma separator, or we could use some string formatting, or whatever we need to do. That's perfectly fine. I'm just keeping it super simple. And so we're just going to put a new character there so that it bumps every value onto its own line. Okay, so normally I could do this, right? And that's perfectly fine. If I wanted to do this for an array of strings, then I might be tempted to grab this method and then bring it down here. And then instead of an int array, it's now a string array. And now that it's a string array and not an int array, these are considered unique methods. And then in here, I would replace this with string. And if I really, really wanted to, I could refactor that I to an S so that it makes more sense in the context and so on, right? But now, if I want to do this with an array of anything, with an array of objects, with an array of dogs, with an array of movies, with an array, it starts to get kind of painful, right? Because now I've got to replicate this method over and over again. And even if I do, there's nothing stopping me from coming up with a new type that needs to go through this process. Thankfully, there is something called generics. And generics allow us to define our method in a way that we say, hey, look, no matter what type you send me, the process is exactly the same. I can't predict every single type you'll send me. So instead, I'm going to put a type placeholder here. I'm going to make sure that you can tell me what the type is, and I'll just work with it. It's a super cool thing to do, but it only works in cases where your process is exactly the same, irrespective of type. And so I'm trying to remember how to write a generic method in Java, but I believe it looks something like this, where we then say, does that work? Nah, that doesn't work. Can I get away with it? Oh, what am I doing? It's not, let's see, is it this? Want to say it's like that. I'm going to have to look up how to do generics in Java. Is it like so? No. Well, bollocks. What if I do that? Is it okay now? Nah, it doesn't like that. Anyway, there's a way to define a type placeholder. In fact, I'm just going to hop over here really quick and we'll do declare generic Java method. It's been a while since I've done one of these, so I've got to see what it looks like again. Generic methods, oh, they put it before the return type. That's my problem. Okay, not a problem. We just grab this and we move it over here. Put a space. There we go. And then every time the type appears, we simply refer to the type. Now, what's this saying? Cannot be resolved. T cannot be resolved to a type. Yes, because it's generic, bro. There we go. I just had to save. All right, so what we're saying here is whenever you call this method, you're going to specify what type you're going to be passing in. Is it going to be integers? Is it going to be floats? Is it going to be dogs? Is it going to be movies? Is it going to be whatever it's going to be? You specify that when you call this method, passing in this case, an array of that type. When I get inside here, I can use this type object in my append if I so wish. Now, I've got to be careful here, though, because if they pass in... in Java, when you're using generics, you can't pass primitives. It has to be a reference type. Because it has to be a reference type, I know that it's safe for me to call the .toString method if I need to, which is a method that every object has. Every reference, every non-primitive object has the toString method. And the toString method says, take this object, this non-primitive type, and turn it into a string version of itself. That's what it says. And if I pass in the object by itself, it will call that toString method for me by default, because the string builder needs a string, not some arbitrary object. So it will take that object, call toString on it, and then take the string version. We can talk more about this in the future, especially as we get deeper into objects, but I wanted to show you this concept that if you can start thinking about methods in a way that makes them context free, then the more you can do that, the more reusable your methods become. Just like in our console IO library, we have a whole collection of methods that are effectively context free. All they know is this method needs to get an int from the user and return it. This method needs to get a string from the user and return it. This method needs to get needs to ultimately derive a Boolean from the user and return it, and so on, right? But those methods don't know how they're being used other than to get the type of data that they return. They don't know if like in the case of prompt for bool, the method has no intelligence to know that we're asking if the user wants to continue, or we're asking if the user prefers sushi to pizza, which, by the way, I do. It doesn't know if we're asking if they want to go left or right. It doesn't know those things. It only knows that we're trying to get some true or false result based on user input. And similarly, prompt for int does not know the context of what we're asking for. It only knows that we gave it a string to display to the user so the user would know what we were asking for, but the method itself has no intelligence to know the context it's in. And because of that, because we've been able to generalize the context of the method, that method now applies to any situation where you need a number from the user within some acceptable range. And sometimes that acceptable range is int min and int max. And if that's the case, all you're doing is saying, like, enter a number. If that's all you need, great. The method doesn't care. It will get you an int from the user in the range of int min to int max. It's perfectly fine. That method is written so that you can get any number you need from any range you want from the user. So the more we can generalize, the more that we can generically state what we want that method to do, the more that we can reuse that method in other contexts, the more we can use that in other code. I got a message the other night, or last night actually, I got a message from a student. In fact, if you don't mind, I'm not going to reveal who it is because I don't have the permission, but I will say really quick. There we go. In the Discord server last night, there was a person who posted, and I quote, "I have learned what you mean by code is sexy. My console code is gorgeous." Once you learn how this thing can make your life easier, you start to appreciate it way more, way more. So I loved that comment. I was like freaking out as a teacher in a good way, right? Like I was like, it was like watching your kid hit their first home run. It was like, yeah, I'm proud of you, man. Okay. I do not yet see anybody in the queue who wants to talk and wants to discuss certain things. So I'll tell you what we'll do. I know that I've been getting a lot of questions about can you please go over how to make a jar again, which is totally understandable. And by the way, I will be making a dedicated YouTube video to exporting your code as a jar when you're building a library. And I will also do another video about adding that jar to a new project so that you can use that library. Okay. I keep watching the device I'm using to monitor the stream, and it keeps going into buffering mode. I'm worried that that's happening to you guys too, and it's freaking me out. And I wish it wouldn't do that. I need to improve my setup. That's what I need to do, but limitations right now, right? Okay. All right. So let's go back over here to this demo. Let's I don't know. Let me think for a second here. What could we do in a library very quickly that is not console.io that then we could use as our demo? What could we do? Well, I'll tell you. I was thinking about this last night. Wouldn't it be cool if we could write the method to get a random number within a range, an inclusive min and inclusive max? If we could write a method in that range write a method that would give us a random number in that range. And that way we only have to call that method, and then it kicks us back a random number without us having to declare all this other stuff, right? Okay, so let's do this. Let's make a new Maven project. And in the new Maven project, and I'm going to go ahead and just do, oh, that's right. Once you've made a group, someone told me about this. Once you've made a group, you can go ahead and do that. Oh, that's right. I'm doing video code demo. Ha ha ha. Yeah, we'll do that. No, I'm going to go back to the other group. So the reason I have two groups here is one of them is just for my general coding tutorial stuff that I want to do in, just on YouTube, period, as opposed to particularly for this class. And then we have the artifact ID in this case. I'm going to call this I'm going to call this Krebs util. Krebs util lib. There we go. Why not? And then we have our project Krebs util lib. Of course, you should name it after yourself, not after me. And then inside here, we're going to go ahead and grab this horse main Java, and we're going to add new, and we're going to say package, and here I'm going to put the lib package. That's my library package, inside of which I'm going to add a class, and I'm just going to call this one utilities. Now this is kind of interesting. We haven't talked about this yet, but normally when we build a class, normally when we declare a class, we name the class in the singular, because the idea is that this class represents a global notion, or it represents the template for building a single one of whatever this is. For example, if I were building a class to represent what a movie is, I would call that class movie. And then that way I could create as many movie objects as I want, each one representing a different movie. And so we normally name these things in the plural. I'm sorry, in the singular. We don't name it in the plural because that would imply that this class represents some plurality of things. However, if you're building a utility class or some helper class that has nothing but static functions, and it serves maybe multiple purposes, or each function is sort of like its own job. That's true, but it covers a number of bases. You can name this class in the plural. I call this thing utilities because I'm never going to make an instance of this class. I'm just going to use methods or utilities found within that class. So this is kind of a more generic name that we don't normally do, except in the case of a class that is meant to be a helper class. Now, in here, I'm going to have this is, because I want to build this a bit more correctly, I'm going to make this private. I know we haven't really discussed what this means yet. So let me just say that if I make something private, it belongs purely to this class, and only the owning class can see it, and only the owning class can use it. It is not publicly visible. It is not publicly accessible. So this class is going to have something internal that only it can use. And so I'm going to make a private static, and I'm going to make it a random object, and I'll just call this RNG, and then we'll new it up. And the reason I'm doing this is so that I have one random object that I will use for every time I need something random. I will just use this one object inside of this class every time this class is called to generate some random value. Of course, I get the red squiggle worm, so I got to do a Control-Shift-O to get my imports, right? Perfect. And then I would have some public static int method called get random int. And then I would have int min and int max. Now the idea here is that this value, this thing is going, or the min and the max, it's exactly what you've seen before. Why did I do a semicolon? It's exactly what you've seen before. The min is going to be an inclusive minimum. The max is going to be an inclusive maximum. We're going to have to think about that a little bit because we're going to have to do some math, and we don't want to accidentally take this number out of bounds temporarily to causing wrapping to occur. So we're going to have to do some clever thinking here, but don't worry, I think we can make this work. I'm going to do my best to make it work, and if we get stuck, then we can fall back onto some pretty standard practices. All right, so inside of this method, we're going to have an int. I'm going to call it randnum. I'm going to just set it equal to 0 for a moment so that I can return randnum. I'm doing this purely to satisfy the compiler while we write more code. That way, the compiler, if it ever finds an error, it's in the new code, not just because it didn't return something, right? All right, so so then inside of this method, we want to see, now my video looks like it's frozen. I'm just looking at my monitor right now. It looks like it's frozen, but it doesn't look like it's buffering. So that's weird. Anyway, maybe I'll see if I can, yeah. Let me see what I can do about that. Anyway, here is my, okay, here we go. I do want to declare, an int upper bound. But in order to make this work, I've thought about this quite a bit. And the idea is, consider for a moment that they send us int max as our upper bound and int min as our lower bound, right? Then I'm trying to think this through now, gosh dang. That's going to take us into very strange territory, because we are going to be, what am I doing? No, sorry. I accidentally tabbed over. If they give us int min and int max, remember that we're going to take the maximum and we're going to subtract from it the minimum, and then we're going to add 1. And then outside of that, we're going to add the minimum again, right? To create our shift. That's normally how we do this. But if I subtract a negative, if I take positive 2.147 billion and I subtract from it negative 2.147 billion, I am now adding that value. That means I'm taking my int and adding to it a value that's going to take it way outside the value of an int. Way outside. It's going to be a big problem, right? And And I've been trying to figure out, okay, so how can we set this up such that we get the right min max? And as I've thought about this over and over again, I'm like, you know what? The answer is if you have int min is equal to, well, if it's anything, let's see, how do I do this? If int min and int max are the regular integer int min, int max, if that is our boundaries, we just have to return next int. We don't have to do anything special. It's only in the cases where we're not hitting those boundaries that we need to consider how we're going to apply a shift and do all that stuff, right? So the first thing we got to do is we got to check to see if min equals integer dot min value. And I'm trying to remember if I know I've shown this to you before, but we haven't talked about it very much. But the integer class, which is the reference type version of the primitive int. So int with lowercase I is primitive. Integer is not primitive. It's a class that represents those primitives. And this class has certain data points and certain behaviors. One of the data points it has is the absolute minimum value of an integer. It also has the absolute maximum value of an integer. So I can come in here and I can say, hey, if min equals the minimum of an integer and max equals the maximum of an integer, if that's the case, then we can say that random simply equals rng.nextInt, because that is the range of values that nextInt normally produces. It goes from the minimum to the maximum, so then we're okay. So our code would look something like this, right? Where I realized just a moment ago that I was still on face cam, so I apologize. So we would check to see if minimum equals integer.min value, and we'd see if max equals max.max value. We would do that. If that's the case, do this. Otherwise, we're going to go into figuring out what our upper bound is. Our upper bound equals, and let's take our max minus our min plus 1. And this should be a safe concept. It should be a safe concept. But for me personally, I want to make sure that everything is treated like a long during this mathematical process so that we don't accidentally go into strange territories where an int is concerned. Think about this for a second. Yeah, so if I have a very large positive number and I have a very deep negative number, I don't want to say small negative number because that gives the wrong impression, but if I have a significantly deep negative number, that might, when we subtract a negative, take us into long territory. So we're going to do long math here, but if I do long math here, I can't store it as an int. So if I hover over this, it'll tell me, hey, there's a type mismatch here, da-da-da-da-da. And I'm like, don't worry, when we're done, then this should be an int when we're finished. I'm thinking through this again. Gosh dang it. I'm really worried about some of the consequences here. I think the problem that I worry about is when they pass us a negative value. If they pass us a negative value, this gets really weird. Maybe that's the problem, is that we have to check for negatives. For right now, let's write this code, just since it's just a simple demo. Let's write this code as if we're not receiving any negatives for right now. But we should readdress the negative problem. I know there's a way to fix this. We just got to work through it and figure it out, or do the research and find that someone else has already solved it. All right, so then here we're going to do rand num equals, and we're going to use rng.nextInt, passing in our upper bound. But remember that we're also going to apply the minimum as our shift. So assuming that they've only given us 0, or I should say non-negative numbers. Assuming they've only given us non-negative numbers, then here we go. We're going to do this. Oh, wait, guys, wait. There's a possibility that they've sent us data that makes our jobs impossible, right? What could they send us that would make our job impossible? Well, if you've been working on console.io a lot, you've probably already thought of it. Here we go. If min is greater than max. If they give us a range of minimum and max that the minimum is greater than the maximum, our job is now officially impossible. And if our job is officially impossible because they gave us bad arguments, we had better throw a new illegal argument exception. The min value cannot be greater than the max. I'll get rid of the period this time. There we go. All right. So now they can't give us a minimum greater than the maximum. That's important. That's good that we guard against that. And then we'll go ahead and declare our return value. We will check to see if they want the full range of minimum and maximum. And if that's not the case, then we'll go into our standard max minus min plus 1 approach. And then we'll do random num, and then we'll do our normal random get. And then we'll return random when we're done. Again, we should readdress this for cases where minimum is in the negatives. But we'll come back to that later. I'm worried that all this hopping around is muddy in the water, and I don't want to do that. The whole purpose of this is that I've created a library class where we have some method that I can get some use out of, right? So all of our random logic is now here, and we can improve this with time. But for right now, for the purposes of our demo, let's go back over here to our package explorer, and I've determined, technically I should test this first, right? We're not done until we test. Okay. Let's go here to the source main Java. Let's add a new package. And let's do tester. And then we'll hit finish. And we'll do this. And then we'll do a class. And then we'll do lib tester like we did before. And we'll give it a main. And we'll do all this stuff that we normally would do. And I'll do an import lib.utilities. Now here, if I want to test it, I would go through certain things. I would say, here's public static, excuse me. And I might even do, if I'm doing like a manual test, then I might print out either Booleans true, false for succeed, fail, or I might print out the actual result, something to that effect. I just have to decide how I want to test this thing, right? So for right now, I'm gonna go a cheap route, and I'm gonna say, here's this void, and then we'll do generate random num underscore returns min. In other words, I can give it a minimum value, and given enough generations, given some large sample of generations, I guarantee that the minimum is produced. So in this case, I'm going to do int min is 5, and int max is 17, just being arbitrary here. And then what I want to do is I will do a Boolean min produced, and that will start at false. And then I will do a while loop, because I'm really just concerned that this thing gets hit at all. I shouldn't do a while loop. We'll do a maximum. We'll do a for loop. For int I equals 0, and I is less than, and you know what? Let's declare another int here. Let's say int max runs, and let's set it to 1,000. If I do 1,000 random gets and I never get the minimum value, chances are it's not producing the minimum value, because I've only got a sample size here of 13 numbers, right? I've only got 13 numbers. So if I've only got 13 numbers, 1,000 random gets, chances are I'm going to get my minimum. If I'm not comfortable with that, I can always add another magnitude, 10,000 runs. Let's let it run 10,000 times and see if it produces that number. Let's do that. I'm about to use a for loop in a way that you may not have seen before. I want to run this for loop so long as I is less than my max runs, which will give me 10,000 runs, and the min has not been produced. Now I want you to think about that for a second. Look at my loop condition. My loop condition is set up to loop based on two things, not just one. As long as I haven't maxed out my number of runs, this loop will keep going. But that's also only if the minimum has not been produced. Since I'm using the AND join here, the AND compound operator, what that says is if at any time either of these is false, the entire thing is considered to be false, and the loop will stop. AND means both must be true for the whole thing to be true. So if just one is false, it's all false. So if I run out of max runs, or if the minimum gets produced, then it's going to stop the loop. Watching the stream on my monitoring device does not give me hope. Okay, here we go. So I'm going to say that min produced equals, and then I'm going to call my utilities class dot get random, where I pass it the min and the max. And then when that value comes back, I'm going to compare it to the minimum I passed in. If you want to see this broken out just a little bit, I could say random equals, and then we will call this method to produce that random number. And then I will compare that random number that I received to see if it equals the minimum I passed in. If it does equal the minimum I passed in, then min produced turns to true. This loop will stop. If it's not the minimum, this remains false. Or I'm sorry, yeah, this remains false, and the loop will continue. Notice that I'm saying not min produced. That means that when min produced is false, it's treated as true. And when min produced is true, it's treated as false. That's what that bang does in this case. So once I've done that, once the loop is done, it's either hit the maximum number of runs or it has produced the minimum, right? And so I need to say something useful like minimum value was produced. And then I can say, in fact, if I want to, I can just kind of say minimum produced. Like that's the name of my, or I should say returns min. I can name this after my method name, basically. Returns min, and then I can just say min produced. So that if the minimum was produced, this will say true. If the minimum was not produced, this will say false. And I will know if this test passed or failed, right? And then inside of my main, if I want to run this particular test, I just have to call this method. Generate random num returns min. So now I can go ahead and execute this thing, and sure enough, it produces the minimum. The other thing I would probably want to do, and I'm not going to take the time to do this right now, but I want to apply this exact same concept, except I would want to write a test for something like generate random num underscore let's say returns less than min. Chances are if I'm writing tests, I want to have a bunch of trues, and I don't want falses to mean good things. So let's say does not return less than min. So if it does not return less than min, then that should be a true, and that's a good thing, right? And then I would write this method in exactly the same fashion as I did the one above, just with I'm checking for different things, right? In this case, I'm checking to make sure it never produces a value less than the minimum. I got to make sure that that's the case. And I could come up with like a billion tests, but I'm not going to do that right now. The point is, I've tested my code. I'm happy with my code. Now it's time to produce the jar. Yay! Yay! We're only 45 minutes into the stream and finally got to the part you guys care about. Here we go. All right, so I have built a library I wish to export. I have determined that, I want everything that's in my lib package. I obviously don't want what's in my tester package. I don't want to export my test code. So I right-click on the project itself, and I go to export. When I get there, you'll have general install Java. Blah, 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 blah. We want to go to Java, and we want jar. We don't want runnable jar because remember, a library A library is about reusable code that is not executable by itself. It's about taking that code that's useful and usable and plugging it in to another project, and that project is going to be runnable, but not the library itself by itself. Remember, the library is like flour in cooking. It is technically edible, but you don't want to use it on its own. You want to incorporate it in other projects. So we're going to take this jar file and we're going to say next, and it will show you all the projects in your workspace, but it will only have selected anything out of the one that you right-clicked earlier. Remember that square, I have 3 marks here, right? I have empty, that means nothing is selected, and I have checkbox, which means everything is selected. I'm going to deselect that, and if I select one thing inside of an outer object, you'll notice it gets a square. The square means that some sub items are selected, but not all sub items are selected. That's what that square means. So I want to make sure that I've selected my lib package, and if I want to see what's inside there, I can always click on the lib itself, and it will show me all the classes that are inside that package. In this case, I've only got the one class, and that's what I want to export, so we're golden. So here we go. We have everything that we wish to export. And then export generated class files and resources. Yep, that's right. And then down here, we need to choose a destination. Now, if I do browse, it takes me to kind of like a default location. Not very cool. And I could navigate around and find out where this thing is. And there's nothing wrong with that. Sometimes what I do is I will instead hit Windows E to open up File Explorer, because chances are if I've been somewhere a number of times, then I can get there really quickly, like so. And I can go to, actually, let's see, I think in this case, if I'm doing a Twitch demo, oh crud, I'm trying to think of where I am now. I think I'm down here, Twitch code, and Java, and then here is Krebs util lib. Now what I like to do is I will either have a directory dedicated to libraries that I just export, but I have found that, you know, over time I'm going to change that code as I get better at coding or as I find bugs that I didn't find before. And so I like to keep the produced jars in the same directory as their source code. And then maybe I might copy the current version out to a central library repository that I use on the regular. But for your purposes and for my initial purposes, I tend to store the libraries in the root of their project. So let's go ahead and go into Krebs util lib. And then if you've done this in Windows Explorer, then yeah, you get this breadcrumb trail. But if you click next to it, you get the fully qualified path, starting at the root of your main drive all the way through to where this thing is located. So one more time, I navigated, here is my collection of projects. Here is the root directory of the one we're currently working on for the library we're testing. If I double click that, it gets me into the project directory. I can tell because there's a proj file, right? There's a project file. And so if in Windows Explorer, I go ahead and click the address bar, then it will give me the fully qualified path, starting with C:, and all that stuff. If I then hit Control C to copy that, I can then minimize this, come back to my Java export window, and paste it right in. That's exactly where I want this library to be located for right now. But then I also have to add a backslash and then give my library a name. So in this case, I'm just going to call it Krebs util lib, because this is a library that I don't have to turn in to my professor, and then do .jar. You have to do that because if you don't, it will try to default to a zip in many cases. So to be sure that it's a jar file when you're done, you want to make sure that it's .jar at the end. And then I hit finish. Now once I hit finish, if you look over here in the Package Explorer, our jar now appears as an object in this project, which is great news. So that is how you export the jar, okay? Because this is recorded and I'll put this on YouTube, I'm not going to repeat myself now because you can always just back up and watch it again. I'm going to just double check over here in the general area and in the help and all that stuff. Let's go to help. Ah, yes, Cece, thanks for asking that. So a little bit ago, Cece asked if I would show how to do prompt for input. So I teach 3 sections of Intro to CS, and in the morning section, just by consequence of certain questions being asked, we got to a point where we pseudo-coded that method together, and then we ended up just fully coding that method together. And because I did that for my morning class, it's totally legitimate, 1, for you guys to get the code that we wrote in class if you'd like to have it. And 2, if you'd like to see it demonstrated, sure, we'll do it. Because I did it for one class, I'll do it for all my classes. And CC asked if we could demo that today. So you know what? Yes. Yes, we can. And in order to make that happen, I'm going to switch workspaces. So I know I'm still on face cam, but that's intentional this time for once, right? So I'm going to go ahead and switch over to a class where we didn't do that demo. I'll wait for my Eclipse to open up. While we're doing that, I'm going to wet these pipes. Okay. All right, so here is the console.io.java class. And I was helping with some examples of things, and so I'm going to get rid of all this. I'm going to change this back into a to-do. This method needs to be implemented, and then just return 0D. Technically, I think I could just return 0 and it'll promote, but I like to be a little bit more explicit. All right. The reason I'm doing that is so that all of my console IO will compile and that way I can spot errors a little bit more easily. Here is the pseudocode for what we did in class previously. Here's the pseudocode. And we went through and talked about this at length. So the idea here is if they give us a prompt that is useless, and the only way we know it's useless is that it's null or it's the empty string, or when I trim it, it's empty. And I refer to, if it's going to be empty or trim then empty, I just refer to that as trim empty. Because if you trim an empty string, you still get the empty string. If you trim a white space string, you get the empty string, so it's the same thing either way. So if they give us null or a trim empty string, then we're going to throw a new illegal argument exception because we know that prompt is not going to be useful to the user, therefore it's not useful to us. If it's not empty, we're going to, and it's not just white space, we're going to assume it's useful. We have no way to analyze those semantics, but we shouldn't have to do that. And then we're going to declare a buffered reader. We're going to get our string input variable and default it to null because that's an automatically bad state. And then we're going to declare a Boolean is valid and initialize it to true, is invalid, is initialized to true, because those two things, the string being null and this thing being true, is going to determine ultimately whether or not our loop continues. And then we go into our loop where we prompt and we try to read, and then we validate, and then we print if it's invalid, and then we loop until it's good. Once it's good, we return the input. Okay, so that's just the bird's eye view. Okay, so let's go ahead and implement this thing. So my pseudocode here is really strong, and here's how I know it's strong, because I can go underneath a single line comment and I can do exactly what it says just in Java. So if prompt equals null, or prompt.trim.isEmpty, get used to these two things. Get used to asking if a string is empty using the isEmpty method, because it's super useful. But I can't call a method, I can't call any method on an object that is null. So I need to make sure I check for null first. And the way we check for null, this is the only time, guys, this is the only time that when we compare a string to anything, we use the double equal symbol. If we're going to compare a string to null, we use double equals. The reason is, technically, null is an address in memory. And there's only one null address in memory for your application. There's only one. So if anything is null, it has that address. So if I compare it with double equals and it's null, it's guaranteed to be true. If it's not null, it's guaranteed to be false. But in all other cases with a string, when we're looking for equality, we never use the double equals. Only in the case of checking for null do we use double equals. Otherwise, we use the method dot equals or dot equals ignore case, depending on the situation that we're in. So first we have to check for null, because if this is null, this operator says this whole thing is automatically true. We don't even need to check this right side. If this is the or symbol, remember earlier when we had and I said and says if one thing is false, the whole thing is false? This is or, and it says if one thing is true, the whole thing is true. So if this were to be true out of the gate, then the whole thing is considered true. It doesn't even check this, which is good, because if prompt is null and I call trim on it, it will throw an exception. So by doing prompt equals null with the or operator, it stops the checks the moment the first thing is true. If the first thing is false, then it will check the second half because it's safe, and it needs to see if this is true. Because if this one is true, the whole thing is true, and we move on. If they're both false, the whole thing is false. Okay, cool. So now we're inside of the, we're going to pretend that the if came out true. It's either null or empty. And now we're going to throw new illegal argument exception. And then we say the prompt cannot be null, empty, or just white space. Now the developer will know what they did wrong if they get this exception. All right, cool. So now let's go to our next line of pseudocode. Declare and initialize a buffered reader called Buffy. Look at that. It tells us to declare and initialize and what to name it. So buffered reader Buffy equals new buffered reader, because we're initializing it, right? We declared a new buffered reader called Buffy, and we're going to initialize it to a new instance of buffered reader, because we got to have an instance in this case. New input stream reader, which wraps around system.in. And then we'll declare string input, set it to null, and then we declare Boolean is invalid and set it to true, because that is going to put us in a state where our loop will automatically false until, where our loop will automatically recycle until the user gives us valid input. Following the pseudocode, here is the do keyword. Down here is the while while, and then it says the condition is while is invalid is true, so is invalid. We need to talk about this too, guys, because I saw this a lot yesterday, and we've got to have this talk. And so there is my do while. And, let's have this talk right now. I've been seeing something a lot that I want to fix right this moment. And just so you know, I understand why you do this, and I understand the intuition behind it. I want to fix this because real developers don't do this. Plus, it's leading to a lot of simple mistakes. Remember that these parentheticals are just Boolean evaluations. If whatever you put in here evaluates to true or false, it's acceptable. If it does not evaluate to true or false, then it's a compiler error, right? Compile time error. I've been seeing a lot of people do this. Yes, this is logically correct. Yes, this is readable to you. I get that. This is not what real developers do, and it's horribly wasteful, and it's highly redundant. We don't do this in industry. First of all, one of the second biggest reason is it leads to simple mistakes. What I saw this, I kid you not, I saw this 4 times yesterday. That is not a comparison. That right there is assignment. And all it's doing is checking to see if the assignment worked. Because if the assignment worked, it's going to basically return whatever you assigned in this case. So this is not producing the outcome you want, and it's not what you want to do. What you really mean is, hey, is invalid considered true? So you've got to do a comparison. But we don't do this in the industry. And here's why. First of all, this variable returns a Boolean. That's one Boolean, right? This literal is also a Boolean value. That's two Booleans. And then this operator returns a Boolean result. That's three Booleans. And here's the interesting thing. When this is written the way that it is, then when is invalid is true, the operator returns true. When is invalid is false, the operator returns false. Which is exactly the same thing as not having this here at all. When is invalid is true, it will be seen as true. When it's false, it will be seen as false. Comparing it to true does exactly the same thing with three Booleans as would be the case with one. So we never, ever, guys, and I told you this before, but I'm going to tell you again right now, we never compare to a Boolean literal. It's okay to take two different Boolean variables and compare them because sometimes one is true and sometimes one is false, and it's variable, and we can't predict that. But we never compare to a Boolean literal. It's not useful. It doesn't mean anything. But wait, Mr. Krebs, what if I want to see if it's equal to false? What if false should be true and true should be false? Did you just hear what I said? If you want this thing to loop when this Boolean is false, then you just got to bang it. Because this says when it's not the case that this is true, keep going. In other words, when this variable is false, the bang will treat it as true. When this variable is true, this bang will treat it as false, and so on. So this is when you want the Boolean to be true, loop when the Boolean is true. This is when you want it to loop when the Boolean is false, and that's it. Please stop doing this. It's not that it's logically incorrect, it's that it paints you in the wrong light. Yeah, I know you're new to coding, but you don't want other engineers to know you're new at coding. Okay? This is something that real engineers don't do. We don't do it. It's wasteful, it's redundant. Okay, I've beaten that horse to death with another dead horse or something. Here we go. Now we need to print the prompt. And remember, with prompts, we like to keep it on the same line as the input. And what prompt are we printing? What prompt are we printing? Oh, we're printing the thing that we were given that we already verified was useful, right? Or at the very least, not null, not empty. So we print the prompt we're given. And then check this out. Try to do this thing. Here's the catch. And what are we catching? We're catching IO exceptions. In the case that an IO exception, in the rare and extremely uncommon case that an IO exception is thrown, right? So if this is the case, I will do a quick sys out and I will say, warning, an IO exception was thrown. And hang on a second. I think that we want to add to it in this case. I think there's get message. There we are. So if an IO exception was thrown, every time an exception is thrown, it may contain a message. So I want to make sure that the message is printed with my message. That way I can see why the IO exception was thrown. Because remember, by catching this exception, we're not going to break the application. It's not going to bubble up to the surface. But I still want to print a message that's useful so that the developer and or the user sees what's going on. Yeah, this is red. Why is this red? Well, I haven't imported the IO exception type yet. Wait a second. Oh, it says oh, no. It's red because it's currently unreachable because I haven't done anything to throw an IO exception. But I'm about to. Input equals my buffered reader dot read line. And now the compiler's happy everywhere. So now I'm trying to set the input to the read line. Remember, if this should throw an exception, if this does throw an exception, this variable does not get reassigned. The assignment never happens. If this thing throws an exception, the assignment does not happen. Instead, we go to the catch will occur, and then we move on, right? And in fact, that comment there needs to be here. There we go. And then we move on. So what do we do in this case where we move on? Well, now we're in the analyze state. So there's a cycle here, right? Prompt the user, read the input, and take any necessary action with that input. Then analyze to see if it's valid. Now we're going to analyze the input. So I'm going to set is invalid equal to, and then what counts as valid in this case? Valid in this case is input does not equal null. I'm sorry, is invalid. Is invalid is input is null, or input dot is empty and allow empty is false. So not allow empty. Notice I'm not dot trimming this. And the reason I'm not trimming the input is because we don't really know the context of this prompt. It might be that they are being asked for how much white space they want to inject. So an all white space input is legal. That's okay. It's not this method's job to determine if white space is valid or not. It's the method's job to make sure that it's not purely empty and it's not null. In the case where allow empty is false, the input should not be empty. But white space is not empty input. It's not empty input. It could be valid. We don't know. So we can't get rid of it. So we're going to go ahead and tack on the semicolon. Also notice that I wrapped this and condition in parentheses because I wanted to make sure that these two conditions were treated as compound. I don't want them to be separated and evaluated separately of each other. They need to be evaluated and then their results combined. So input is invalid if it's null, because null is always invalid, or if it's empty when empty is not allowed. If it's empty when empty is allowed, that's still valid. So it's only invalid when it's empty and allow empty is not allowed. Okay. And by the way, Mr. Nuttall, yes, I can show an example of null pointer exception. And you don't have to throw that, but when it gets thrown, you should know what that means. Okay. When you don't have to throw it, but when it gets thrown, you should know what it means. So here we go. Now I have analyzed to see if the input was valid or invalid, right? And if this Boolean is true, then I know that they gave me garbage input. If this Boolean is false, I know I've got valid input and I can move on. So if is invalid is true, remember we don't compare it, we just take it as it is, then inform the user. The input was invalid. Please try again. Okay, cool. So now we have our input loop, right? Prompt, read it in, catch any read exceptions, analyze for validity. If it's invalid, let them know. Loop until valid. If it is valid, return it. Guys, this is the entire prompt for input method. It looks a little chunky because we have comments before every line of code, but we also have some white space for readability. If I look at this from 138 to 175, that makes it 38 lines of code. If I remove all of the comments, it's more like 22 lines of code. If I remove the white space, it's more like 18 lines of code. If I put the curly braces on the same line as their lines, it gets even smaller, right? It's actually not that many statements. If we look at the number of statements, if we include if as its own thing and then throw as its own thing, we don't have that many statements here. Not really. This is prompt for input. Now, really quick. Anytime you need a string from the user, Anytime you need a string from the user, guys, anytime you need a string from the user, big wink, then you can use this method. You can use this method anytime you need a string from the user. But wait, Mr. Krebs, what if I need a number from the user? Okay, how do we get numbers from the user? First, we get a string, and then we parse it, right? So in this two-step process, do you need to get a string from the user? I'm just curious. This method can be used anytime you need a string from the user. So keep that in mind. All right. I don't know why I collapsed that. It's habit. This method is yours to keep. You can have this. I have given you one of the 8 methods in this assignment. It's important that you get this assignment 100% correct. This will help you get there. Okay? All right. Let's go to Mr. Nuttall's question. Mr. Nuttall's question is, can you show us an example of a null pointer exception? Oh, hi. You startled me. Hey, guys. So last week we had Luke on the stream. Now we have Leah. Leah, the camera's here.
Hi.
This is my daughter, Leah. You straight up scared me. I've been playing a lot of scary games lately and watching a lot of scary movies, and so now I'm like nervous about everything. And plus my daughter's a ninja, aren't you?
Yeah.
Do you want to say anything to the people at home? These are my students. Do you want to say anything? You don't have to. It's okay. Just curious if you did.
I just love you, Dad.
I love you too. Okay, I'm going to get back to teaching them stuff, okay?
Okay.
All right. Mwah. Love you.
Whoa. Misha, you scared me.
And now my dog scared my daughter. If you watched the Outlast stream, my dog can scare people very easily by just walking in a room. All right, here we go. Let's talk about the null pointer exception. So I'm going to switch back over to my code for demonstrating stuff on Twitch. I'm going to switch over to that workspace. So the idea of a null pointer exception. So remember that primitives can never be null. Primitives can never be null. That means that also in Java, everything that is not a primitive can be null. And remember that null is the absence of anything, right? Null is non-existence. And you know, we've gotten really comfortable. We've gotten really comfortable with here is some object that I have, or some class. Here's a class. Classes also can never be null because they're not objects yet. They are the blueprint for an object, but the class itself is not an object. An object is when you have to build a new something. You have to say a new buffered reader or a new random or a new movie. Anytime that you new something up, you're building an object based on the class definition. And we haven't gotten into the specifics of class versus object, but we will. And so anytime you have to make something new, anytime you have to make a particular instance of a class, that's when you have an object. And that's when the object could potentially be null. So for example, let me go ahead and collapse that down, and then I'm going to make a new public static void demo null pointer exception. Let's pretend for a moment that I'm going to use random as an object again because it's easy to use. I'm going to go ahead and say random RNG equals new random. You've seen this before. This is not new. I do have to import the type so that it knows what it is. So now I've got a variable RNG and then I'll have int rand num equals RNG.nextInt. Just like so, and then I will go ahead and just print that out. Rand num, and then we'll just concatenate random onto there. Great. And if I then demo the null pointer exception and hit play, you've seen this before. This is nothing special, right? Everything here works the way it should. But imagine for a moment that I never actually newed this up. I never actually made this new. In fact, if I were to declare this instead of here, what if I'm gonna back this up for just a second, and I'm gonna bump this up to the class level. and I'm doing our training wheel rule. And if I run this again, it still works the way that it should, right? There are no surprises here. But what if I never actually made this anything at all? Notice that when this is at the class level, it's allowed to not have an initialization, whereas in the method can see it's not initialized and goes, whoa, bro, you gotta tell me what it is, right? By default, what is this thing going to be? Is it going to be a new random object? Is it going to be a default random object? Or is it going to be something else? If I hit play, I get the null pointer exception. The reason I got the null pointer exception is because I tried to dot into it. Remember, the dot means go into. I tried to say, hey, look, RNG, random object. I'm going to go into you and find a method, or I'm going to go into you and find a data field that's publicly exposed, or I'm going to go into you and find some other object and then tell that to do something, and so on, right? That dot means go into. If the object exists, yeah, I can go into it, no problem. But null is the absence of existence. It doesn't exist. So when I say dot go into, right? There's nothing there. I'm trying to access something that doesn't exist. And because of that, that's an exceptional situation. Doing the job is now impossible. I can't go into it. It doesn't exist. Therefore, we get a null pointer exception. So what you're seeing here is that by default, objects, if they're not initialized, default to null. It's the same thing as just saying RNG equals null and then hitting play again. I get the exact same result. I have to instead initialize this to some instance of random, either point to another existing one or make a new one. Once the object exists, it's not null, and I can go ahead and hit play and it comes out just fine. So Mr. Nuddle, that's what a null pointer exception is. You never have to throw it. If your object is ever null and you act on it, it will get thrown for you. To that end, we should make sure that we code against null. We code defensively. And so what I might do here instead is say, hey, if RNG does not equal null, then go ahead and do the thing we normally do. Otherwise, I might produce a message like the RNG is null, so that I don't throw an exception, right? So here I get the number, no problem. If I take this back to null, now I get the other message, but I don't throw an exception because I checked for null first. And yeah, you can do not equals null or equals null. Either way is fine as long as your logic lines up with the consequence. That's the only reason I did not null is because I had the code here first. That's all. So hopefully that answers your question, Mr. Nuddle. Okay. Let's see. I don't see any other questions in the queue just yet. I don't have anybody in the waiting to be. I don't have anyone who wants to talk on the air, if you will, who wants to talk live. If you would like to talk live, please let me know. I'll drag you over, not a problem. Or the mods can drag you over as well. Let's see. So previously we made our library, right? We made our actual library object. What's cool about this, about having this library project in the same workspace as my other projects, is if I decide that I need this library to be handy, if I want this library to be in my Twitch QA demo, for example, I'm going to go ahead and just close all these so that we start fresh. I did that by right-clicking the tab, by the way. If you right-click the tab, you get all the close options. And in my Twitch demo, let's go to, there's my driver, here's my demo. Yay. Here's all the stuff that we've been doing since earlier today, right? So I'm going to go ahead and collapse these down. I'm going to get rid of this random number generator. Might break some stuff in roll dice, though. That's okay. I'm going to fix that in just a second. And so I've gotten rid of that random number generator. And because I want to use my utilities library instead. So the cool thing about having my library project in the same workspace as my other projects is now I can select my jar, and holding the control key, I can drag and drop it into a neighboring project. See, now that jar exists not only in its original project, but in the project that's going to use the jar. And now that that jar is present, I did a drag and drop. Now that it's present, I can right click it, go to build path, add to build path. And then I get this reference libraries thing that has this inside. What that just did, the whole add to build path thing, the build path tells the compiler what to include when it's compiling. So when I bring in a jar that's not part of the standard Java libraries, the compiler does not immediately recognize it. I have to instead say, hey, compiler, just so you know, this jar that's located inside this project, I want you to add it to the things that you're compiling. That way it will take the new code I'm writing and the jar as it is already compiled, and it will compile them together into a single output. So that's what add build to build path does. If you don't do that, the jar is not part of the compiler's awareness, and none of your code will work that uses the jar. You have to add it to the build path. So now I've got my jar added to the build path. Now that that's the case, I'm going to go into my roll dice method. This was a previous example, and notice that we're using RNG, next, int, and we have all this stuff, right? This min and this max, and then we're doing this stuff. This is all the logic that's inside of my library. All I have to do is figure out what the min and the max needs to be. So I'm going to go ahead and replace this instead with my utilities dot and oof. Do I have a naming collision? Oh, I might have a naming collision, but that's okay. That's okay. I'm going to fix that. So let's see. Java.util_ran. Okay, we're going to do an import lib dot. There's my utilities class. I might have a naming collision. This is going to be great. No, it's okay. It sees it more locally, so we're fine. I'm going to pass it the min that I've determined. I'm going to pass it the max that I've determined. And now, instead of having to do all the logic every single time, I'm just doing a little bit of logic here to make this happen, right? And remember, the way I wrote this last time was instead of simulating the number of dice being rolled, I instead determined, based on the number of dice and the number of sides, what the min and the max would be. So on 3d6, for example, if I were rolling 3d6, the minimum would be 3 because I've got 3 dice, and the maximum would be 18 because I've got 3 6-sided dice. And so that's why the minimum is the number of dice and the maximum is the number of dice times sides. But now I can use this getRandom, and on top of that, I do not have a random object in this class anymore, and I do not have to do the min-max logic. That's all encapsulated in this method, in this class, in this library. So that's how this gets useful, right? All right. I've talked your ears off. It is now almost 11:30. Are there any other questions that you have at this point? In fact, I know that there's a delay, so I'm going to go ahead and ask. We got to make sure that everyone has their questions answered in a useful way, right? All right, so this video so far we've covered the notion of generalizing our methods and removing context. If we can remove the context from a method, then that method becomes useful in any context that needs that process. Sometimes you can't. Sometimes you can't generalize your methods more than they already are. But when we're trying to get a number from the user, that's a general process. When we're trying to get a string from the user, that's a general process. When we're trying to print an array of stuff, that's a general process, right? We can generalize that down and make that process, that method, reusable. We also talked about, we went ahead and implemented the prompt for input method. Not a problem. That's yours now. You can have that. Let's see. Hang on one second. I see someone talking about... Well, we'll get back to that in a second. We've talked about how to export a library, how to bring that library into another project, how to manually test that library. We've talked about all those things. We've actually covered quite a bit of ground. I know that when we get into these situations, we're very tangential, but we've covered all of these things so far. And we covered the nature of the null pointer exception, which is something that we haven't really talked about much. We also covered why it is that we don't compare Boolean variables to Boolean literals, or we just don't compare to Boolean literals ever. We don't need to. All right, so let's see, Cece is saying that she's still not sure about for loops and arrays, but she's going to check out the previous streams just to kind of get a handle on it. Plus, I have the for loops all posted. Did I get the fourth one done? I'm trying to remember if I did the for each loop. I've got at least the for loop posted, and now I can't remember if I did the for each loop. Huh. I don't think I did. I think I've got to do that video. And then arrays. I do want to make a video on arrays. I haven't done that yet. First, I'm going to make a video on how to export your library and a video on how to import it, separate of this stream. Although this stream would suffice for that as well. Let's see. Okay, and one of my graders is saying that he's noticed that a lot of people are still confused on what parameters even are. So let's just demonstrate that just really, really fast, okay? Because we can do this very quickly. Imagine for a moment that I had I'm purposely being simple here because I'm trying to show the principle. And so I'm going to do something really super simple. Let's just say I have add ints, and it takes in 2 ints, right? It takes int x, and it takes, or let's see. Let's say that its job is to add 2 ints. We're going to keep it like that. Add 2 ints. Inside of the method, I might have int x, and it defaults to 10, and it's int y, and it defaults to 14, and then I'm just going to return x plus y, right? That's great and fine and dandy, but outside of this method, if I'm like int sum equals and I call add 2 ints, then I'm going to get the result of this method. And what's the result of this method going to be? If I hit play, oh wait, whoops. That's right, I'm not running the right thing just yet. Hang on. It's right here. Open up this driver. Oh, I just gotta get the right main method basically. So now it's 24, right? In fact, if I were to put this inside of a for loop and I were to say int I equals 0 and I is less than 10, so I'm gonna run this 10 times, and then I do I plus plus. If I were to run this 10 times, what you would see is that every time I run this thing, I get the exact same result every time. I might as well call this method return 24, right? Because I'm just getting the same result over and over. And the problem is that this method has local variables that this method is setting, but it's hard coding them. We're doing this because the method has to add 2 ints and it can't add numbers that don't exist, so it's got to have numbers, so it just makes them. If I wanted to add 2 different numbers as the developer, I could go in and I could say, oh, okay, that's fine. Let's just make this 13 and 1, right? But now the same problem exists just with a different number. If I want this to be more useful, then these values need to be dynamic. They need to come from some other source. They can't just be hard-coded. So what we do is we say, okay, look, this method requires 2 ints to add together. But it's not this method's job to figure out what those ints are. It's not this method's job to go get the ints from the user, or to go get the ints from 2 other methods, or to go get the ints from some constants. It's not the method's job to do that. Instead, in order to add 2 ints, it just needs to be told what these ints are. So we declare 2 parameters, int x and int y. What we're saying is, whoever calls this method, whatever code uses this method is going to provide these two ints, and we don't care where they come from. We don't care if they're from the user or from some other method or whatever. What the add two ints method cares about is that it is told what these two ints are. It doesn't go get them, it's given them. So you can look at parameters as if it's like hands being held out by the method, waiting for data to be passed in. When the data gets passed in, it holds on to that data in these parameters. What's cool about these parameters is they are still local variables. They are still variables local to the add two ints method. But they are variables that get set by the caller, not by the add two ints method itself. So it will be told what the data is, it will store the data in X and Y, and then it will use that data. But it does not have to generate or acquire that data itself. So now up here in run, when we call add two ints, I can either hard code it. I can say, yeah, it's these two numbers, right? And then add two ints functions and says, okay, I can add those two together and we have no problems. Or I can go get these numbers from the user and add them together. Or I can say utilities dot get random number between, oh, let's just do 1 and 10, right? 1 and 10. And then let's do it again. Right here. I'm going to pick a number between 1 and 10. I'm going to pick another number between 1 and 10, and I'm going to add them together. Notice now that you and I cannot predict what these outcomes will be. We know what the range of outcomes will be, 2 to 20, but we don't know what the actual outcomes will be. And notice that add two ints does not know which two ints it's going to receive until it has been given them, right? But it doesn't matter. Add two ints is going to be given two ints to add, and it can do its job. And then we get these 10 results, or we run it again and we get 10 different results, or we add it again or we run it again and get 10 different results. A parameter is a piece of data that must be given to a method so the method can do its job. That's what a parameter is. For example, when we did console.io and we had prompt for input, we had to pass the prompt in because the method had no idea what the message should be. It could be anything. It could be anything. So the method does not know what that message should be. Only the caller knows what that message should be. So when the caller tells prompt for input to run, the caller has to pass that message in so that the method knows what to say. The same thing is true here. Add two ints doesn't know what two numbers to add. It has to be told what two ints to add. So that's what parameters are. Data that the method needs to do its job, and that method cannot know. It has no way of knowing in advance what that data should be. So it has to be told what that data is. Hopefully that makes sense. If you're still struggling with parameters, come see me in person and we can do some other examples together. Dwight, I see what you're saying. Not a problem, but don't put that in the help message. Let's put that in general, or you can even message me privately and let me know that that's what you want me to play, because I think that would be totally cool. I've never played Amnesia and I totally want to. All right, so keep that to the general conversation, please. Let's see. Yeah, and I apologize. I realize that the buffering today is just rough, but when I put this out on YouTube, it should be the whole video without any buffering problems. So we should be good there. All right. I'm checking to see if there's anything else that we need to talk about. Hopefully this clarifies what parameters are. Hopefully this clarifies how to make libraries and all that stuff. I'll wait for another moment here. If there are no new questions, though, we've covered quite a bit of ground today. I'm hoping that these sessions, I realize the buffering is a problem, but at least on YouTube, you can see what's going on. And if you're on Discord, in truth, I'm only talking in the voice channel that I'm in and nobody else is in, so you probably can't hear me there either. Maybe what I'll do in the future is I will speak in a public channel, and then you guys can listen there. But anyway, point is, If you watch this back on YouTube, hopefully these sessions are helpful to you, because that's really what I'm going for. I'm just trying to help you guys out. We've never done this before, where we do after hours and on the weekends tutoring like this in a live stream situation. We've never done this before. This is all brand new. And to be honest with you, traditionally in my intro class, I'll usually have a failure rate of between, it kind of depends on the quarter, but it's between 20 and 30%. So about 25% is my failure rate. And to be honest with you, while there's a good chunk of that comes from students who they change their mind about being at Newmont in general, or they just don't like coding, or whatever the case may be, there are certain things that I can't fix. But there's also a percentage in that group that I think could be fixed if they just had more opportunities to ask questions, if they just had more insight, if they just had more examples, and we just don't have that time at school. So my hypothesis, my hope, and my desire here is that these sessions actually improve your chances of understanding the material so that you can do the work, so that you can pass the class. I don't want you to just pass the class. I want you to understand, so that passing the class is a natural consequence, right? If you understand the material and if you do the work, you'll pass the class. So I want to help you with that. I want to help you understand. I want to help you synthesize, and I want to help you get the work done in a legitimate way. And then, of course, you'll pass the class because you'll be awesome. That's how this works, right? Okay. I don't see any other questions in this channel at this time. I'm just going to take a quick look, a quick glance. I don't see anything new, and I don't see any commentary. Let's see. Okay. Yeah, I don't see anything really pertinent at this point in the questions. There's some other comments, but they're unrelated, so we don't have to worry about that. You guys have access to email me. I'm doing my best to be responsive. Of course, I've got a family and kids and all that, and I've got to take care of them too, but I try my best to be responsive to the emails. Please don't hesitate to email me. Please don't hesitate to email the graders. We're doing our best to support you guys, and we would love to hear more from you about what you're struggling with, about what we can make clearer. I also want to, doing the streams with code examples, that's cute and all, but I also want to come up with like more physical objects that I can show you examples with, like the way arrays function and things like that. So I'm going to work on that. I'm going to work on visual aids and object lessons that I can show you to help you understand the principles at work. Past that, if the stream is good for you guys, then great. I will work on my side on getting improved equipment situations, so that we can make this a smoother experience for you guys, because this is all about you. So until next time, then, you guys are awesome. I appreciate you. Thank you for being here. And as always, be epic. Don't suck. And I'm going to do my best to make sure that this stream ends only after everything has happened and it doesn't cut off midstream like it does sometimes. So thank you guys very much. Have yourselves a great day, and good luck.